Okay everyone, so in this presentation, I will explain a work solution for a trigonometry problem involving bearings and a binomial expansion problem. The focus is on understanding the reasoning process step by step. First, we have a trigonometry problems. The problem describes a cyclist who starts at point R and travels 2.3 km in the direction of 197 degrees. She then changes direction and rides for 1.8 km in the direction of 107 degrees to point S. We are asked to draw a sketch, find the distance from R to S, and determine the bearing from R to S. First, we draw a fully labeled sketch. From point R, we draw a north line as a reference. The first path, RA, is drawn at a bearing of 197 degrees from north with a length of 2.3 kilometers. At point A, another north reference is drawn, and the second path, AS, is drawn at a bearing of 107 degrees with a length of 1.8 kilometers. So here is the fully labeled sketch of the situation given in the problem. Next, we're gonna find the distance between points R and S. The difference between the two bearings is 197 degrees minus 107 degrees, which equals 90 degrees. This means that the paths RA and AS are perpendicular. Therefore, triangle RAS is a right-angle triangle with the right angle at point A. So here we have the line segment of RA is perpendicular to AS. So using the Pythagoras theorem, the square of RS is equal to RS squared plus AS squared. Substituting the values, we calculate RS as the square root of 2.3 squared plus 1.8 squared, which gives approximately 2.9 kilometers. So the distance between R and S is 2.9 kilometers. Next, we have to find the bearing from R to S. To find the bearing from R to S, we first determine the angle at point R inside the triangle. So using the sine rule, we have RS over sine A equals AS over sine R. We substituting the value and we got sine R equals 1.8 times sine 90 degrees all over 2.9. And then we get the value of R is approximately 38.4 degrees. Since the line RS is rotated clockwise less than the line RA, we subtract this angle from the original bearing. Therefore, the bearing from R to S is 197 degrees minus 38.4 degrees, giving approximately 158.6 degrees. So we have the bearing from R to S is 158.6 degrees. Now we move to the binomial expansion problem. So here we have the expansion of 3x plus p over x to the power of 8, where p is more than 0. So we are given also that the term in x to the power of 4 is equal to the coefficient of the term in x to the power of 6. Then we have to find the value of p. So to solve these problems, we have the binomial expansion formula. The binomial expansion formula states that a plus b to the power of n can be written as the sum of from k equals 0 to n of n choose k times a to the power of n minus k times b to the power of k. So in this equation, a is 3x, b is p over x, and n is 8. Substituting these values into the formula gives the expansion of 3x plus p over x all to the power of 8. The general term becomes 8 choose k times 3x to the power of a minus k times p over x to the power of k. When we simplify the powers of x, the term becomes 3 to the power of 8 minus k times p to the power of k times x to the power of 8 minus 2k. This expression allows us to identify any required power of x directly. So to find the coefficient of x to the power of 4, we set 8 minus 2k equals 4. Solving this gives k equals 2. To find the coefficient of x to the power of 6, we set 8 minus 2k equals 6. Then we got k equals 1. We then equate these two coefficients. This gives 8 choose 2 times 3 to the power of 6 times p squared equals 8 choose 1 times 3 to the power of 7 times p. Solving this problem or this equation, and then we got results in p equals 6 over 7. So this completes the solution for both the trigonometry and binomial expansion problems. Thank you for listening.